So I know many people as well, they've asked, how do I tune and optimize sound systems? There's a strong interest, in my methods of system tuning, including dealing with different venues and equipment, and equipment limitations. So one of the key things when tuning sound systems has to do with alignment. So system alignment is very key. So how I can elaborate this is, so for example, this can be your top speakers, right? And this here can be the subs. And this here can be someone standing, listening to the sound. So now, so one of the first thing is before we tune we tune the system, we need to optimize it. So as we are optimizing it, we need to know that, okay, if our subs are there, from here to there, it is longer than from here to there. So which means sound is arriving at different moments. So we need to measure what is the distance from our person in these top speakers. So for example, in this example, this might be, let's just say this is 5 meters, right? And this is for our top speaker. Then we need to measure what is the distance between our person and the sub speaker. For example, this can be, let's say, 8 meters, because these subs are like under the stage or something. So we can see there it is 5 meters, here it is 8 meters. So if you do 8 minus 5, we end with a difference of 3 meters. So now we know, just because of the placement of our speakers and in relation to our person listening, there is a difference in the sources. And we know if the sound arrives at different intervals, we know it's going to cause phasing issues. Okay, that different arrival is going to cause phasing, because our speakers here on the top, they are also playing some low frequencies. Our speakers here at the bottom, they are subs, so they're playing low frequencies. Because there's that distance difference, is going to cause phasing, which means our low frequency is going to be less efficient. So now to optimize this system, we need to basically move this top speaker so that it is in line with this one. So we know there's a 3 meters difference. So all we do is we put these 3 meters delay time into the tops. So one of the simple ways to do that is basically 3 meters times 3 milliseconds, which gives us 9 milliseconds. And if we go into our processor, or it could be a mixer output, we put 9 milliseconds on the output of the tops. And remember to do the same for the left and the right. We put that time, it means we have virtually moved these speakers back. And now, after we put in the delay time, our speakers are literally just above the subs, which then means this distance now, in that distance is now the same. So our speakers are in phase. So which means the low frequency is going to sound good. So this simple thing, this is basically system alignment. It is part of that tuning process. It is part of that optimizing the system to get the best from it. So after you have done the optimization of the system, and you must understand, before all of this, you must make sure you've got the right presets, okay? And then after you've done the right presets, we fix that everything is aligned. And then there are other tools that we use, like, for example, smart software. Smart software, what it does is, I can have a mic and send this a signal to this speaker, send a signal to this speaker with a reference signal. It will tell me the difference again in distance. And then I can also check with this software to see how are these speakers interacting as far as low frequency is concerned, because that is where the phasing happens. And then from there with this software, I can then align it. It gives me again this time. I can align it. But sometimes what happens is different speakers, different manufacturers, they've got different times in their processing. Like for example, for a sub, for example, for a processor to be able to process the full range audio signal to have that low frequency, it may take 10 milliseconds. So you just looking at the physical, you see the 3 meters, but you won't be able to know that this particular speaker internally also has an additional 10 milliseconds. So that's where software comes in to help you further analyze and further optimize. So for me, I use software now to get me to be even more efficient. But in your own case scenario, if you don't have the software, you can just do these physical checks, and you are basically technically aligned in terms of phasing, because more and more manufacturers, they are making it very simple, such that if you just do the physical checkings and you make it aligned, their system is already more efficient. So for me, after all of that, what I then do is I play my reference music. So I play a John Legend song, and then I play this other guy's song. I forgot his name now. So the John Legend song helps me just see how is the vocal clarity and trueness, because it is just a vocal and piano song. So there must not be too much color in that voice. It must sound clear, not muddy, not harsh. And then the second thing that I do is I play my second song. My second song gives me a balanced reference between a vocal and low frequency. There's like a nice beat to that song. So I can hear the vocal and the low frequency. And then there I can then set my ratios between the tops and the lows. And after that, I know whatever I bring into the sound system is going to sound true. I do these things where I would do an event. There are 20 choir mics. They're all wearing headsets, or they've got handles, and there's like 40 of them, or it's a 400-piece choir. Like, I know if I check one mic and I do my high pass properly and I fix any other color from that particular mic, I know when the 400-piece choir comes or the 40-piece choir comes on their handles, it's going to sound true to the source. But all of that happens because I've basically optimized my whole system. So really, one of the key things in being able to optimize a system for you to be able to have good results on a system is basically the efficiency of your tools. And smart software is like one of the references in the market. There are other softwares, some for free, some less expensive, but for me, I prefer to work with the industry standards because I know they will spend so much money in their research and development, so I don't have to worry about other things because they've done all of that work under the hood already.